following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Let's take a look at figure 31 here. We have two scenarios that we're looking at. A, when light speeds up, and B, when light slows down. Let's take a closer look at 31A first. Looking at figure 31A, if light speeds up upon entering a new medium, meaning the index of refraction for the medium of the refracted ray is less than the index of refraction for the medium of the incident ray, then as you see here, the angle of refraction will be greater than the angle of incidence. And in this scenario, the light bends away from the normal. Secondly, if we take a look over here, as light slows down, we see that if the light slows down in the new medium, then the index of refraction for the medium of the refracted ray here is greater than the index of refraction for the medium of the incident ray. And the angle of refraction will be less than the angle of incidence. In this scenario, as you see, the light and the ray will bend towards the normal. Now, in summary, the angles of incidence, reflection, and refraction are all measured with respect to the normal. And the angle of incidence and angle of reflection are always the same. Moreover, when we see our light bends away from the normal when entering a material with a lower index of refraction, and then the angle of incidence will be less than the angle of refraction. Conversely, light bends toward the normal when entering a material with a higher index of refraction, and the angle of incidence will be greater than the angle of refraction. Okay, great. Let's proceed now to our next slide. Example refraction 1. What is the speed of a light ray in glass as it passes from air into glass? And the index of refraction for glass is 1.50 at an angle of incidence of 0 degrees. Now, before we attempt the problem, let me ask you a question. In such a scenario, is there going to be a change in direction as the ray goes from the air to the glass? No, it's not, right? And the only thing that is going to occur, there's going to be a change of speed, and that's because the angle of, the index of refraction for the glass is going to be greater. Now, let's demonstrate as to why that is. If we take a look here at figure 32 for just a moment, firstly note that the angle of incidence is 0 degrees. Thus, the transmitted ray travels along the normal and therefore is not bent at all, meaning a ray oriented perpendicular to the surface does not bend, regardless of the mediums. Now, moving on, we can find the speed of a light ray. If we take a look here, we can find the speed of a light ray in the glass through the index of refraction equation. Next, let's write down our givens, and we should commit the speed of light in a vacuum to memory if we haven't already done it yet, which is 3 times 10 to the power of 8 meters per second. And we're being told that the index of refraction for glass is going to be 1.50. And what is it that we're looking for again? That's right, it's going to be this speed of light in glass. Great. Next, what we can do is we can go ahead and write down our equation, the index of refraction here, and we can go ahead and rearrange our equation to find the speed of light of the light ray in glass. Now, once we go ahead and we fill in our values, as you see here, we find that the speed of light in the glass is 2 times 10 to the power of 8 meters per second. Now, as we stated a few slides back, light is 2/3 its vacuum speed in glass, as you see here. However, that's still much faster than we experience on a normal basis. Great, let's move on now to our next question. Example refraction 2. Describe the path taken by a beam of light in air as it passes through a glass window pane at 40 degrees to the normal and exits on the other side. For this question, we know that the light is going to change direction twice and refraction is governed by Snell's law. So what we'll do is we'll take a look at a visual depiction of Snell's law taking place, and we'll proceed from there. If we take a closer look here at figure 33, we see here that initially we have an incident ray present in a medium of air where the index of